This workshop is the second intro class to Python programming. During our last workshop, we learned a few programming concepts through Python, including the following. We wrote the Hello World program in Python, which is the first program students write for any computer language. We learned how to use the Python print function, which prints information to the console and is common to almost all programs written in Python. We learned about programming variables, named storage locations which hold specific values, which can be referenced multiple times in a program. We learned about data types, including strings, integers, and floats. We learned about lists, which are variables with one or more items associated with them. Items in a list can be referenced by a process called list indexing. The last thing we learned is Python basic operators, which are used to perform arithmetic operations. New topics for today's session include the following. Part 1, String Formatting. Part 2, Basic String Operations. Part 3, Conditions. String formatting lets us use variables in strings, allowing for dynamic print output. When formatting in this way, we use the % symbol followed by a letter as a placeholder for the variable in the string. After the string, we include the % symbol again. Then in parentheses, we specify the names of variables in the order they appear in the string. Note that inside of the string, we must pair the % symbol with a letter, depending on the data type of the variable we're inserting. %s for strings, %d for integers, and %f for floats. Before doing the exercise for this section, let's quickly go over tuples, since they appear in this exercise. In Python, tuples are very similar to lists, with one important difference. Whereas lists in Python can be modified during program execution, tuples are fixed and cannot be modified during program execution. Visually, we can distinguish between lists and tuples by the use of square brackets or parentheses, respectively. Let's practice using string formatting with Python at the following URL. In the first interactive Python window, we see an example of string formatting, in that the value of the name variable is included in the print function through the inclusion of the %s operator. The second window illustrates the use of multiple variables in string formatting, provided the variable names are included in a tuple. The third window shows how string formatting in Python really doesn't require that data types be identified correctly to be included in the format, and all instances of variables can be referenced by the %s operator. So if we replace the value of myList with an integer or a floating point number, the string formatting can accommodate these all, even if you identify them all as strings. The next short section covers the C formatting symbols for a few different data types. And finally, we arrive at the exercise for this section. We are instructed to modify the script in such a manner that the following is printed out to the console. Hello, John Doe. Your current balance is $53.44. Please pause the video now and attempt to solve the exercise on your own before proceeding. In this setup, we should modify the value of the format string variable on line 2 like this. Then click the Run button, and the exercise is solved. This is the end of Part 1. Strings in Python are considered an object class, and classes in Python have special operations called methods that can be applied to those class objects. Use of methods in Python code can be identified by the name of the object, followed by a dot, then the name of the method, then parentheses, and any arguments the method requires inside of the parentheses. Use of functions in Python code can be identified by the name of the function, followed by parentheses, and any arguments the function requires inside of the parentheses. Note that, in both functions and methods, inclusion of parentheses are required, even if there are no arguments required for the function or method to execute. The Len function is used to count the number of indexes contained in an object. In the case of strings, it returns the number of characters, and in the case of a list, it returns the number of items. The index method is used to locate the first instance of the argument within the object. The output is the number of characters into the string where the argument appears, counting from 0. Here, the output of the method is 4, because we're starting our count from 0. The count method returns the number of times the argument appears in the object. Note that we don't count from 0 in this case. Just as we can index lists to retrieve the item contained at a specific position, we can index strings, with each character in the string counting as a separate item. Remember, when indexing in Python, counting starts from 0 instead of 1. What's more interesting is the ability to select specific slices of the string. Here, we've isolated the third and fourth letters from the string Python. Inside the brackets, we indicate the character to start from, then a colon, then the character that marks the stopping point. So 2:4 indicates to start from the third character and stop at the fifth character, not including it in the output. If a second colon is included in index slicing, the number to the right of it indicates the number of characters to count by when slicing. In this output, we see that the slice starts from the first character, ends before the 10th character, and skips every second character. The last part of string indexing slicing we'll cover is using negative index numbers. If a negative index number is used, the index starts counting from the end of the string instead of the beginning. So here, we're printing out the string index for grapes at the -1 position, which is the last letter. When indexing, if we include a colon without a number to its left, the first colon will have a default value of 0, and the second colon will have a default value of the number of characters plus 1. Here, the whole string is in range, due to the inclusion of 2 colons with no numbers to the left of them, and we're stepping through the characters in reverse order, one by one. The upper and lower methods output all of the characters in uppercase or lowercase, respectively. The Startswith and Endswith methods are used to test whether strings contain the specified argument at the start or end of the string, respectively. The split method converts a string into a list with the separation between items indicated by the argument given. Let's practice our basic string operations in Python at the following URL. On the web page, we click the blue Next Tutorial button to proceed. In the first window, we're introduced to strings as text that is enclosed in either single or double quotes. We can print both of these variables out with the same print function, like so. In the second window, the Len function is used to return the character length of the A-string variable. The reason the number 12 is returned is because the count includes spaces and punctuation marks. The third window illustrates use of the string index method, identifying the first instance of the letter O. Remember, The output shows 4 because this method starts counting from 0. The fourth window shows use of the string count method, returning the number of times the letter L occurs in the A-string variable. The fifth window starts a section on string index slicing. Because we start counting from 0, the slicing here starts at the fourth character, L, and stops at the seventh character, W. The sixth window shows the full scope of string indexing, with the first number in the brackets representing the starting point, the second number as the stopping point, and the third number as the step, or number to count by. If we modify the third number to 2, we see that only every second character is printed out. And if we set the third number to 3, then every third character is printed out. The seventh window concludes string index slicing with an illustration of negative string indexing, which reverses the direction of the string. The eighth window covers the upper and lower string methods, which return strings in all uppercase or lowercase characters, respectively. The ninth window includes the Startswith and Endswith string methods, which check for specific string arguments at the beginning or end of strings, respectively. The 10th window includes the split string method, which converts a string into a list, with a specific delimiter character used to separate each entry. Here, the A-string variable is converted into a 2-item list, since the delimiter character, the space, only appears once in the string. If we include a print function at the end of the code, we see that this is the case. We've now arrived at the exercise. We're instructed to modify the S variable so that the output matches all of the comments. Please pause the video now and attempt to solve the exercise on your own before proceeding. This will be better if we start from the bottom of the code. On line 32, it indicates that there should be 3 words in the string. On line 28, it indicates that the string should end with OME exclamation mark. On line 24, it indicates that the string should start with STR. If we consider these 3 requirements, we can deduce that the string is supposed to be strings XXX awesome exclamation mark. Then we go to the requirement on line 2. The length of the string should be 20 characters. Then the requirement on line 5. The first occurrence of the letter A should be at index 8, which is the 9th character. And finally, the requirement on line 8. The letter A should occur twice in the string. Taken all together, a sensible value for the string would be strings are awesome! Exclamation mark. Then we click on the Run button, which completes the exercise. This is the end of part 2. Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming. In the previous workshop, we worked with string, float, and integer data types. Now, because we will be learning about conditional statements, we'll learn about a new data type, the Boolean. The Boolean data type can have either one of 2 values, true or false. and which value is returned depends on the statement that is evaluated. In the example above, we're using the Boolean operator double equal signs to compare 1 to 1 and 1 to 2, respectively. We'll be discussing Booleans more later, but for now, we need to understand that statements equating to true or false is the basis of conditional statements, which leads us to conditions are how programs make decisions as to which instructions to perform at a specific point in program execution. Generally, conditions trigger when a statement evaluates to true or false. So let's discuss what this means exactly. The basic conditional statement in Python is the if statement. And if statements are written in code blocks like the following. Here, the program will print one message if the password variable is the string mySecretPassword, and print another message if it is not. If statements start with if, then a Boolean equation, then a semicolon, then an indentation on the next line, followed by instructions if the condition is met, then on the next line, else, then an indent on the next line, followed by instructions if the condition is not met. The else portion of the code block is optional. After the if statement code block finishes, program execution continues on the next line. We can use any of the above Boolean operators in if statements. When using the AND operator, both statements to the right and left of the operator must be true in order for the overall statement to evaluate to true. In this case, since the variables birthday and today's date are the same day, the if statement returns true and the program will print happy birthday. When using the OR operator, either statement to the left or right of the operator must evaluate true for the overall statement to evaluate to true. In this example, the if condition would not trigger if both statements to the left and right of the OR operator were false. The IN operator is used to check if there is a specific item within a container object, such as a list. Here, the print instruction is executed because the string listed in the name variable is included as an item in the party guests list. The is operator is used to compare whether an object is exactly referencing another object, as opposed to matching the values contained within. The not operator is essentially an inversion of whatever Boolean value is paired with it. Not paired with true evaluates to false, and not paired with false evaluates to true. Let's practice our if conditionals in Python at the following URL. In the web browser, click on the blue Next Tutorial button to proceed. The first window shows the evaluation of a few Boolean operators. Remember, the single equal sign is an assignment operator for assigning values to variables, and the double equal sign is a Boolean operator, which means equals to. The second window shows an if statement with the AND clause, which triggers if both Boolean statements return true, as well as an example of the OR clause, which triggers if either Boolean statements on either side of it return true. The third window covers if conditions with the IN operator, which checks if a specific value exists in the object to be iterated over, typically a list. The fourth window emphasizes the structure of code blocks in Python. A code block must be created each time an if conditional, a loop, or a function is created. A general rule of thumb is that if a line ends with a colon, a code block will follow. The elif condition is used here, which allows for another condition to be checked if the first condition returns false. To see how the execution flow works, let's set each of these conditions to print out a different message. When we run the code, the if condition returned false, but the elif condition returned true, so its message was printed. But if we swap the values of the statement and another statement variables, then run the code again, we see that the if condition message is printed. And if we set the values of both variables to false, we see that the else condition message printed. The fifth window shows a very simple if statement and its corresponding else code block. The sixth window discusses the is operator, which compares objects and not values. The is operator only returns true if the two objects being compared are the same object. When we run the code, the second comparison returns false because the objects are not the same. However, if we change the value of y to x, then the code returns true, since y is the same object as x. The seventh window covers the not operator, which inverts whatever Boolean operator is paired with it. The not operator is often used to check if a certain variable is empty or not. So it can be used when writing programs that take user input to check if the user is providing blank input or not. Now we've arrived at the exercise for this section. We're instructed to change the values of the variables on lines 2 to 5 so that all of the if conditionals in the rest of the code evaluate true. Please pause the video now and attempt to solve the exercise on your own first. The statement on line 7 requires that the number variable be greater than 15. So we can modify the value of the variable to 16. The statement on line 10 requires the first array list to be not empty, so we can put a value in that list. The statement on line 13 requires that the length of the second array list be equal to 2 items. So we adjust the list so that it only contains 2 items. The statement on line 16 requires that the length of the first array and second array lists be equal to 5. So we can adjust the number of items in the first array list to 3 items to meet this requirement. The statement on line 19 requires that the first array list not be empty, and that the first item in the list be the number 1. So we can make the first item in the first array list 1 to fulfill this requirement. The statement on line 22 requires the second number variable to be false, so we can set the value of the second number to false. Then click on the Run button to complete the exercise. This is the end of part 3. Let's write a program that uses some of the concepts we learned in this workshop. We should write the program in one of the Python windows on the learnpython.org webpage. The program should include one variable that holds the value of an integer. The program should print out the string x is an even number if the variable is an even number, or x is an odd number if the variable is an odd number. The value of the variable should substitute in for x in the printed statement. For example, 7 is an odd number. The program should be run 3 times, with the value of the variable set as 0, 13, and 256 for each execution, respectively. The program should report 0 and 256 as even numbers, and 13 as an odd number. We'll present a possible solution after this, but you should attempt to write your own program now. A possible solution to this exercise is the following. If we go back to the learnpython.org webpage and paste in our solution code, when we run it with the variables 0, 13, and 256, the program reports the numbers as even or odd as expected. Did your program also report the numbers as even or odd in an accurate way? Let's review the programming concepts we learned in this workshop. String formatting is a way for us to include variable values in strings by using C-style syntax. Strings in Python have a number of different functions and methods that can be useful for obtaining specific details about the strings. We can also output slices of strings through string indexing. Conditions are used in programs to determine a program's course of action. They rely on the evaluation of Boolean statements to determine if certain instructions are performed or not. In the next HackerFrogs AfterSchool programming workshop, we'll continue learning Python with the Learnpython.org website. The next workshop will cover the following topics: loops, functions, classes, and objects. Looking for more study material on this workshop's topics? See this video's description for links to supplemental documents and exercises. Until next time, HackerFrogs!